In our lesson today, you're going to have a nice review of special right triangles, and then we're going to move on to some trigonometry. In this first section of special right triangles, we're asked to find the length of each missing side in simplest radical form. Okay, and so looking at this here, I can tell that this is 5 and this is 5, and this is the side missing right here, and this happens to be the hypotenuse of my right triangle. And so in order to find that missing side, I know that I can use the Pythagorean theorem. So I'm going to take the two legs and square them, 5 squared plus 5 squared, and that has to equal my missing side, my hypotenuse, and I'll call that c squared. Okay, well 5 squared is 25, so this is 25 plus 25 equals c squared, which means that 50 is equal to c squared. In order to get the value of c, we're going to have to take the square root of each side. So the square root of c squared is just c, and we're going to have the square root of 50 when we take the square root of the other side. Okay, and now to simplify this in simplest radical form, okay, well remember that 50 is the same as 25 times 2. So c is equal to the square root of 25 times 2. And when I take the square root of 25, that is equal to 5. So this is going to be simplified down to 5 radical 2, which is going to be the length of my missing side, 5 radical 2. In my second example, I can see I've got 12 here, and this hypotenuse on that right triangle is 12 radical 2. I need to figure out what this missing side is here. This is one of my legs. I'll call it B. And again, if I use the Pythagorean theorem, 12 squared plus b squared is going to equal 12 radical 2 squared. Okay, and if you square 12, you get 144 plus b squared. And if you were to square 12 radical 2, okay, well, we can punch that right into our calculator. All right, if I have 12 times the square root of 2, I get that number, and then if I square it, well, that gives me an answer of 288. Okay, so I'm going to have 288 on this side here. Subtract 144 from each side, and I know that b squared equals 144. When I take the square root of each side, okay, well, that's going to give me an answer. B is equal to 12. So this side right here must also be 12. In my last example, again, I know both of the legs here are equal to 8, and I'm looking for my hypotenuse, which again I'll call c. 8 squared plus 8 squared equals c squared. When you square 8, you get 64. Okay, and when you combine those, 128 is equal to c squared. Now when you take the square root on both sides, all right, c is equal to the square root of 128. And now remember that 128 is the same as 64 times 2. 64 times 2 underneath of the radical symbol. So that when you take the square root of 64, that's the same as 8 radical 2 for the value of c. My hypotenuse here is 8 radical 2. And so hopefully what you're noticing here is that we've been working with isosceles right triangles. Isosceles is when two of the sides have the same value. In this first triangle, these two are equal to 5. Second one, these two were equal to 12. Third one, these were both equal to 8. Okay, this is also in degrees a 45, 45, 90 degree triangle. We know that's our right angle of 90 degrees. The other two angles are going to be 45 degrees. Notice when these two values are the same, I can call them x and x. All right, and if you look for what the length of the hypotenuse is, well, look at the pattern here. 5, 5, 5 radical 2 was my hypotenuse. 12, 12, 12 radical 2 was my hypotenuse. 8, 8, 8 radical 2 was my hypotenuse. So when these two values are the same, x and x, the hypotenuse is going to be x times radical 2. Okay? And so what I want you to do underneath in examples 4, 5, and 6, all right, based on the values given, I want to know if you can come up with the value of x, the missing side. In the next section, we're again trying to find the length of the missing side in each problem in simplest radical form. And so looking at this right triangle, okay, well, it's not an isosceles triangle like I had in the last case. All right, I've got 1 is one of the legs, x is missing the other leg, 2 is my hypotenuse. So I can use my Pythagorean theorem again. And I'm going to go ahead and write that 1 squared plus x squared equals 2 squared. 1 squared is 1, 2 squared is 4. So when I subtract 1 from each side, well, x squared has a value of 3. So when I take the square root to get the value of x, that's going to be equal to the square root of 3. So this side right here is equal to the square root of 3. In my next example, okay, x is one of my legs, it's missing. 3 radical 3 is my other leg. 6 is the hypotenuse. So when we do the Pythagorean theorem, x squared plus 3 radical 3 squared equals 6 squared. Okay, if we square 3 radical 3, again, I can use my calculator. 3 times the square root of 3 equals that number, and when I square it, I get an answer of 27. Okay, so this is plus 27 is equal to 6 squared, which is 36. When you subtract 27 on each side, x squared equals 9. So when you take the square root, x must have a value of 3. This is a length of 3. With my last example, 8 is a leg, 8 radical 3 is a leg. The hypotenuse is missing this time. 8 squared plus 8 radical 3 squared equals x squared. All right, 8 squared is 64 plus 8 radical 3 squared comes out to be 192. And again, that equals x squared. When you combine these, you get 256. So now when we take the square root of each side, x is going to have a value of 16. And so that's our hypotenuse here. It's equal to 16. Okay, so again, we're going to try and see if we notice any patterns here. These are 30, 60, 90 triangles, okay? 30, 60, 90. My right angle here is the biggest angle. It's across from the biggest side, which is the hypotenuse. My smallest angle, 30, is always across from the smallest side. And my 60-degree angle is always across from the second largest side. And so looking at our patterns, if we notice up here, well, 1 was the shortest side. 2 was the longest side. Okay, over on this triangle, here's my 30-degree angle. Okay, 3 was the shortest side, 6 was the longest side. And then my last one, here's my 30-degree angle, so 8 was my shortest side, 16 was my longest side. So if my shortest side is always x, well, my longest side was always double that, so I can call my longest side 2x. And now I've got to figure out, well, what about that side in between? Okay, so in this one, well, again, my short side was 1. My next leg was radical 3, which is the same as 1 radical 3. In my next example, my shortest side was 3. My second was 3 radical 3. In my last one, 8 was the shortest side. The second one was 8 radical 3. Okay, and so if my shortest side here is x, my second is going to be x radical 3. Okay, so again, my shortest side is going to be x, the hypotenuse is going to be double that, and then the other side is going to be the value of the shortest side times the square root of 3. In question 10, they want us to find the altitude of an equilateral triangle with sides of 18. So I can go ahead and draw in an equilateral triangle. Equilateral means all 3 sides are the same. So all 3 of these sides are 18. So I'm going to write 18 here, 18 here. This one also is 18. And they want us to find the altitude of that triangle. The altitude, if I draw this in, okay, is perpendicular to the base, meaning that it forms a right angle. Okay, and this also does something nice, okay? It splits this side into 2 equal parts. So if the whole thing was 18, each piece is going to be equal to 9. And the other nice thing that this does is that it bisects this angle up here. Now, in an equilateral triangle, all 3 angles are 60 degrees. So that's 60 degrees, that's 60 degrees, and this one up here was also 60 degrees, but since this altitude bisects it, each piece is going to be 30 degrees. And so basically what we have here is 2 30, 60, 90 triangles. So I'm just going to redraw one of them so that we can see what we're trying to do here. Okay, that's my right angle. That was my 60 degrees. This was my 30 degrees. And I knew this was 18, and this was the side that was split in half, which was 9, and this was the altitude, which I'm trying to figure out. Okay, so this is basically what I'm going to do to figure out the value of the altitude. Opposite of the 30 degree is the shortest side, which is 9, and opposite of the 90 degree is the longest side, which is 18. So this is 9, double that is 18. My other side here, the leg, must be the value of what I had here on my shortest side times the square root of 3. That's the value of the altitude here. It's going to be 9 radical 3. In example 11, they want us to figure out the value of x right here. All right, my longest side I see right here is 4. That's across from the right angle. And my other side here is across from my 60-degree angle. Okay, so I've got to figure out what this short side is to help me get to this value here. Well, remember that the short side is always half of the longest side. So if the longest side is 4, then the shortest side is going to have to be equal to 2. And now my other side is always the value of the shortest side times the square root of 3. So this missing side here is going to be equal to 2 radical 3.